Hi, I'm Dat Nguyen. Welcome to part 2 of the hand tracking series. The starting code for this project is slightly different from where we left off in part 1. Be sure to use the files provided in hand tracking part 2 start folder to ensure you have the correct files. In this tutorial, we will track a 3D watch model to your wrist using hand tracking. We will combine hand tracking with gesture control to change the watch belt color with a simple tap. This is the final result. Notice how the watch dynamically tracks the wrist movement. Now tapping on a watch with a color will instantly change the watch belt color. Alright, let's get started. In the left menu, we have an extra folder called Resource. Inside the resource folder, there is a 3D model of a watch and a file called Compass Glass. The first thing we need to do is load the watch model into our reality view. Create a new folder called Classes. Create a new file under the Classes folder called Watch Class. We will store functions related to the watch in this file. Now open Watch Class. Import RealityKit and SwiftUI. Create a class called WatchClass. Create a static function called loadWatchModelEntity. Calling this function will return a model entity of a watch. Add a parameter called scale and set its default value to 1.0. Use an optional binding to load the watch. The name of the file is handwatch.usdz. The model is in the resource folder. Print a success message when it loads correctly. Set the scale after the watch has been loaded. Return the load watch. If the model fails to load, print a failure message and return nil. Okay, let's go back to hand view to test the function. Create a state variable called watchClass and set it equal to watchClass.self. We don't need an instance of the class, we just need a reference. Now to load the watch into reality view. Create an optional binding if var watch model and call the load watch method entity. Set the scale to 0.15 since the default 1.0 will be too large. Add the watch to the root entity. Set the watch to an eye level position for better visibility. We can see that the watch looks great and has loaded correctly into the view. Let's pin the hand view preview so that it would stay put even when we jump to different files. Let's go to hand class. Now that we got the watch, we need to set up hand tracking for the wrist. Just like how we created the fingertip variable and the sphere that tracked the fingertips, we will do the same with the wrist. Create a var called left hand forearm entity with the same type as our fingertip entity and set it equal to an empty array. Go into setup entity and type left hand forearm entity is equal to forearm and call create sphere entity. For the forearm wrist, we're going to use a square instead of a sphere to represent the wrist. Let's go down to create sphere entity function and copy it. Change the name to create square entity with the name, color, width, height, depth, XYZ parameters. We're going to use generate box with size, width, height, depth. Okay, let's go back up to setup entity and add the name, color, width, height, and depth as arguments into the square entity. Add both arm and wrist to the root entity as child. And we can now check the preview. You can see the green rectangle that represents the wrist and the green sphere that represents the arm. Now that we have the entity for the arm and wrist, we need to have them track their respective hand tracking anchor. At this point, see if you could hook up the tracking yourself. It follows the same previous pattern for the fingertips. Alright, I will now explain how it's done. Let's move the hand class file into the classes folder with watch class. Go down to continuous hand update function. Delete some commented code. Create a variable called forearm arm joint transform. The joint we want is called forearm arm. Next, create a variable called forearm wrist joint transform with the forearm wrist joint. Now we need to get the world transform for both arm and wrist joint. Make a variable for forearm arm world transform and forearm wrist world transform. Update the arm and wrist entity in the hand anchor.chirality equals left with their world transform. That should be it. Now let's run the Vision Pro to see if the wrist and arm entity is tracking their respective hand tracking anchor. The green sphere is tracking the elbow, which is the forearm arm anchor. The green rectangle is tracking the wrist, which is the forearm wrist anchor. Notice how the wrist entity is overlapping the hand anchor transform, as seen as the blue sphere. This means both of the anchor use the same data. Everything is working. Let's go back to hand class. We have the hand tracking for the wrist. Now let's create a variable to hold the watch model called watch model entity. Just like we had a setup function for the hand, create a function to set up the watch called setup watch entity. It will accept a parameter called watch model. Update the watch model entity with the watch model parameter. Next, add the watch model entity to the root entity. Go back to hand view and call the function. Delete the root entity dot add child since setup watch entity is already handling that. Call setup watch entity and pass the watch model as an argument. Great, the watch is appearing in our preview. Let's go back to hand class. We need to update our watch model entity with the wrist joint transform. The place to do that is at the left chirality. Use the set transform matrix with the forearm wrist world transform to update the watch model entity. Unfortunately, this method of tracking the watch to the wrist does not work well. When you use the set transform matrix, you are not only copying the position and rotation from the forearm wrist world transform, you're also copying its scale. This causes the watch model scale to go from the 0.15 set previously to the default 1. The next problem is that the watch is not in the correct rotation and position on the wrist. When you reposition the watch to the correct location, the watch will not rotate correctly with the wrist rotation. The solution to this problem is not to directly use set transform matrix on the watch, but instead use it on a parent object that has the watch model as a child. In our case, the parent object will be the green rectangle forearm wrist entity that is already tracking the wrist. Comment out watch model entity Go up to Setup Watch Entity. Add Watch Model Entity as a child to the Forearm Wrist entity. Delete root entity. Since the parent is tracking the wrist transform with set transform matrix, the watch's scale will not be changed. Now you can reposition the watch without causing problems with the rotation. To help us understand the orientation of the hand and watch in 3D space, we will use a compass. By using the compass, we reduce the amount of time needed to use Vision Pro when positioning the watch to the wrist. Go to the resource folder. There is a compass class with a compass model entity method. The method returns a spherical object that points to the positive XYZ axis and positive XYZ rotation. Set the scale for the compass to 3 for the watch model entity since the model scale is reduced to 0.15 when loaded. Let's take a look at the compass in the hand preview. We can see two compass overlaid over the watch and the forearm wrist. On the compass, the positive y-axis is represented by the green line. The negative y-axis is on the opposite side of the green line across the point of origin. This also applies to the x-axis for the red and the z-axis for the blue. The arrow points to the positive rotation of the axis. The color of the arrow represents which axis is rotating. For example, the red arrow is pointing towards the positive rotation along the x-axis. The opposite direction of the red arrow points to the negative rotation along the x-axis. This goes for the y rotation and z rotation. We need to figure out which axis points to the top of the wrist. That's the axis where we would want to point the watch face towards. We also need to determine which axis runs along the width of the wrist. This is the axis where we want to align the watch belt with. Comment out all the code for the left hand anchor entity and also the left fingertips entity. Let's put on the Vision Pro and take a look at the orientation of the wrist with the compass. As you can see in the video, the top of the wrist is pointing towards the negative y-axis, and the wrist width is along the blue z-axis. Here's the watch, and here's the wrist. What rotation would position the watch face with the negative y of the wrist? That would be the negative 90 degrees rotation along the z-axis. Go to Hand class, access the watch transform, then rotation, and set it to negative 90 in the z-axis. What rotation to the watch would align the watch belt with the wrist blue line z-axis? That would be the positive or negative 90 degrees rotation along the x-axis. We'll use the same code but remove the negative sign for a positive rotation and change the axis of rotation to x. The watch face is slightly too close to the surface of the wrist. We will move the watch in the negative y-axis to move the watch above the wrist. Set the y translation to negative 0.015. In the setup entity, change the forearm wrist color from green to clear. Comment out both compass model entities since they are not needed anymore. Since the watch model is now a child of the forearm wrist, it assumes the parent's position. Go to the hand view file and delete the watch model.setPosition. Test the hand tracking out with Vision Pro now. The watch is correctly tracking the wrist. Next, we will work on changing the watch belt color with gesture control. We are now back at watch color. Let's create a static function to change the color of the watch belt. Name it change watch belt color with watch entity and color as parameters. To change the watch belt color, we need to create a new material with the new color and reinsert the material back into the model. This material will be a physically based material called swap material. Set the swap material base color dot tint to the parameter color. Add an emissive color to increase the color's brightness with an intensity of 1. Copy the model's current material into var materials array. The watch belt material is the third element in the materials array. Replace it with the newly created swap material. Set the watch entity model material to the update materials array. Let's head over to hand view to check out the new method. Inside of if let watch model, access the watch class.change watch belt color method. Pass in the watch model and set the color to black. Now check the preview for the change. The watch belt went from the default yellow to black so that the function is working. Now that we can change the belt color, we need to create watches with different colors that can handle tap gestures. Go to Watch class. Create a static function called selectable watch model entity with x, y, z, and scale as parameters. The function will return a model entity that can take gesture input. Create a watch entity by using the load watch model entity function. Once the watch loads correctly, we're going to set the watch entity's position. Add an input target component. Since the shape of the watch is complex, we will use generate collision shape with recursive true. Add a hover effect component. Add a color component with a default color white. Add a return watch entity. Add a return nil if load watch model entity fails. Let's go to the top and create a struct called color component. The color component will store the color of the watch. Every time we change the watch belt color, we will also need to store the color change in the model's color component. Go to the change watch belt color method and check to see if there is a color component. If there is a color component in the watch entity, then save the changing color to the color component. Let's use the selectable watch model entity function to create a watch entity. Go to hand view. Create a if let watch model entity equals to await watch class dot selectable watch model entity. Let's change the watch model entity belt color to purple. Add the watch model entity to the root entity as a child. In the preview, you can see the selectable watch model entity as the purple watch. Now we need to add tap gesture to the reality view. Add gesture to the end of reality view. Use the preset tap gesture. We will target any entity that has the color component. At the end of a tap, we will perform the color swap. First, you need to get the color component of the tapped entity. Use value entity component color component to access the component. We also need a reference to the hand watch entity. With both the color and the watch entity, we will use the change watch belt color method to copy the color from the tapped entity into the hand watch entity. Let's go over to the preview and check if the tap gesture work. Clicking on the purple watch caused the hand watch entity to change color to purple. Now we need to create more watches with different colors. Go back up and create an array called watch color. Add whatever UI color you want into this array. We want the watch to be displayed in a row, so create a var x val and set it equal to -0.5. Now create a loop through the watch color. Move the previous watch model entity code inside the loop. The selectable watch model entity method can take an x value. Change the scale to 0.3 to make the watch slightly bigger. We need to increment the x value so that the watch created are spaced apart by 0.25. Now instead of the purple color, use the loop color. Let's go over to preview and check out the color change. The color change is working great. The hand watch is correctly copying the color when the watch is tapped. Now we are done coding. Let's check the app in Vision Pro. The tap gesture on the watch is changing the hand watch color correctly. This concludes the hand tracking tutorial. I hope you enjoyed the tutorial. Thank you for learning with me.